Absorption is a process in which a substance is assimilated in another substance. The substance that gets absorbed is known as the absorbate, and the bulk phase in which the absorption takes place is known as the absorbent. Absorption in chemical technology is a process in which atoms or molecules transfer from a gas phase into a liquid phase. The difference between absorption and adsorption is that in absorptions, the molecules are taken up by a liquid, adsorbent, or solvent, while for adsorption, the molecules are fixed onto solid surfaces. This is one of the examples of absorption process. It's absorption of carbon dioxide in water. As shown in the picture, 1A is carbon dioxide inlet, 1B is water inlet, 2 is outlet, 3 is absorption column, and 4 is packing. Chemical and physical absorption has several differences. For chemical absorption, the capacity or solubility shows in practice limited sensitivity to the partial pressure of the gas to be removed. High heat of absorption achieved mainly by temperature increase and in high pressure cases, also by pressure reduction or flashing, and potential to reduce level of acid gas to a very low level. And for physical absorption, the capacity or solubility shows is sensitive to the partial pressure of the gas to be removed. Low heat of absorption, desorption achieved mainly by pressure reduction or flashing, and sometimes with additional heating of the solvent, and extent of acid removal limited. The difference between a physical absorption and one in which a chemical reaction occurs can also be shown by figures 12.11a and 12.11b. Figure 12.11. Concentration profiles for absorption: A without chemical reaction, B with chemical reaction. The scales for concentration in the two phases are not the same and are chosen so that PAI per H in the gas phase and CAI for the liquid phase are at the same position in the diagrams. Figure 12.11a shows the normal concentration profile for physical absorption, whilst figure 12.11b shows the profile modified by the chemical reaction. For transfer in the gas phase, 12.34, and in the liquid phase, 12.35. Conditions of equilibrium between liquid and gas. When two phases are brought into contact, they eventually reach equilibrium. Thus, water in contact with air evaporates until the air is saturated with water vapor, and the air is absorbed by the water until it becomes saturated with the individual gases. In any mixture of gases, the degree to which each gas is absorbed is determined by its partial pressure. At a given temperature and concentration, each dissolved gas exerts a definite partial pressure. Three types of gases may be considered from this aspect: a very soluble one such as ammonia, a moderately soluble one such as sulfur dioxide, and a slightly soluble one such as oxygen. Gas requires a much higher partial pressure of the gas in contact with the liquid to give a solution of a given concentration. Conversely, with a very soluble gas, a given concentration in the liquid phase is obtained with a lower partial pressure in the vapor phase. Mechanism of absorption. The two-film theory. According to this theory, material is transferred in the bulk of the phases by convection currents, and concentration differences are regarded as negligible except in the vicinity of the interface between the phases. This film will be slightly thicker than the laminar sublayer because it offers a resistance equivalent to that of the whole boundary layer. Under these circumstances, the concentration gradient is no longer contained throughout the film, and the lines AB and DE are curved. Diffusion through a stagnant gas. The molecules of A have to diffuse through a stagnant gas film and then through stagnant liquid film before entering the main bulk of liquid. In industrial processes, the film thickness is not known. so that the rate equation of immediate use is equation 12.8 using kg. Kg is known as the gas film transfer coefficient for absorption. Diffusion in the liquid phase is much slower than in gases, and mixture of liquids may take a long time to reach equilibrium unless agitated. In steady-state processes of absorption, the rate of transfer of material through the gas will be the same as that through the liquid film. Determination of transfer coefficients. In the design of an absorption tower, the most important single factor is the value of the transfer coefficient or the height of the transfer unit. Wetted wall columns. In many early studies, the rate of vaporization of liquids into an airstream was measured in a wetted wall column, similar to that shown in this figure. Coefficients in packed towers. The majority of published data on transfer coefficients in packed towers are for real small laboratory units, and there is still some uncertainty extending the data for use in industrial units. The general method of expressing results is based on that used for wetted wall column. Coefficients in spray towers. It's difficult to compare the performance of various spray towers since the type of spray distributor used influences the results. Meanwhile, some values obtained by Pickford and Pyle for the height of a transfer unit HL for the stripping of oxygen from water are shown in figure below. Absorption accompanied by liberation of heat. In some absorption processes, especially where a chemical reaction occurs, there is liberation of heat. This generally gives rise to an increase in the temperature of the liquid, with the result that the position of the equilibrium curve is adversely affected. Plate columns. Heat balance may be performed over each plate and the resulting temperature determined. For adiabatic operation, the temperature of stream leaving the absorber will be higher than those entering, due to heat of solution. Packed column. The temperature rise will affect the equilibrium curve and the differential equations for heat and mass transfer, together with heat and mass balance. A spray tower or spray column or spray chamber is gas-liquid contactor used to achieve mass and heat transfer between a continuous gas phase that can contain dispersed solid particles and a dispersed liquid phase. It consists of an empty cylindrical vessel made of steel or plastic and nozzles that spray liquid into the vessel. Spray tower can be very effective in removing pollutants if the pollutants are highly soluble or if a chemical reagent is added to the liquid. Vessel with agitator. An agitator is a device or mechanism to put something into motion by shaking or stirring. An agitator is powered by its impeller, which is the part of the agitator that imparts force to the material being mixed. Examples of impellers are propellers, turbines, gates, anchors, and pedals.